And finally, we have estimating maximal discharges for studied watersheds on the subject date. Specific maximal discharge for Duplinska Reka is 5,5 cubic meters per second per square kilometers, and for Monasterički potok, it is 2.6 cubic meters per second per square kilometers, which is double lower than for Duplinska Reka. Specific maximal discharge is a function of the calculated reconstructed maximal discharge and watershed area, and it is valuable indicator if you want to compare discharges of 2 or more watersheds. So this is table values of maximal daily rainfall of a defined probability of occurrence of a return period at rainfall stations Kladovo and Mihailovets by using Log-Pearson type 3 method statistic technique. So 100 return period rainfall is for Kladovo 127 millimeters, and for Mihailovets it is 146 millimeters. The dimensional curvilinear hydrographs of computed discharges of a defined probability of occurrence for different soil, undecided soil moisture conditions are calculated and presented in these hydrographs. And on the third hydrograph, there is a reconstructing hydrograph for the 15th September 2014. The torrential flood event, which is 86,4 cubic meters per second, and 100 year return period torrential flood has the maximum discharge of 63 cubic meters per second for the Duplinska Reka. The similar hydrographs we have for Monasterički potok in the case of CN1, CN2, CN3. Because of the antecedent soil moisture conditions, we also used for a reconstruction of peak discharge for Monasterički potok CN3. So the peak discharge on the subject date is calculated on 17,2 and the 100 and the just a second, and the 100 year return period torrential flood would have a maximal discharge of 12,7 cubic meters per second. And some comments regarding sediment transport. In the case of similar climate and rainfall characteristics, the great impact in the calculations of the mean annual sediment transport according to the Poljakov-Kosadinov method has the share of agriculture area and areas with poor vegetation. Here, the specific mean annual sediment transport is a valuable indicator if you want to compare results between watersheds, and in table presented, the Duplinska watershed has much higher sediment transfer, which is a consequence of land use patterns than in case of the Monasterički watershed. Presented results indicate an urgent need for torrent and erosion control works, primarily in the Duplinska watershed. Short discussion about the extremeness of torrential flood event. So the probability of occurrence of the reconstructed maximal discharge and return period of the 15th September 2014 torrential flood in the Eastern Serbia is specified and equals to around 250 years for the Duplinska Reka and 40 to 45 years for the Monasterički potok. Rainfall dataset for station Kladovo for a period of 48 years contains two similar maxima, and these are 107,2 recorded millimeters recorded on the subject date, and the second one is 107,3 millimeters, then 93, 91 millimeters, etc., which implies that a 100-year return period rainfall will be probably higher than 107 millimeters. On another side, rainfall dataset for the station Mikhailovets for a period of 57 years contains absolute maximum of 180 millimeters recorded on subject date. And the sunny data series continues with 112 millimeters, then 105, 95 millimeters, etc., which implies that the difference between the primary and secondary maximum will allow a lower 100-year return period rainfall than 180 millimeters. This also entails the greater calculated rainfall of 1%, 0.5 or 0.1% probability of occurrence for Mikhailovets than for Kladovo. We saw the hydrographs and the values for 100-year return period of maximum discharges for CN3, which are mainly used in hydrological studies and hydrological structure planning. So this implemented methodology enables the reconstruction of watershed flood responses associated with the extreme rainstorm and is widely used in Serbia for the purpose of the hydrological structures planning. Special attention is given to definition of the two most important watershed unit input parameters, and these are the CN and the lag time for computation of the maximal discharge on 15 September 2014. And in this paper, the specific maximal discharge for the Dubinská reka is estimated to 5.5 cubic meters per second per square kilometers, and for Monastirski potok, the estimated value is 2.6 cubic meters per second per square kilometer. The September 2014 floods in eastern Serbia will remain historic, given that they took 5 human lives and caused enormous material damage for the local municipalities. So presenting hydrological analysis is a very important part of the flood event documentation, along with the reports of municipalities' emergency headquarters. We developed a conceptual SES-UH model for Dubinská reka and Monastirski potok may have also a significant role in forecasting procedures if we have reliable forecast rainfall data. Thank you for your listening, for your attention, and for further correspondence, I leave my email address.
Dr. Petrovic, thank you so much for a very informative speech. And I would like to get to the question answer part. Please write down your questions in Turkish or in English. So I'll convey to Dr. Petrovic. But before doing it, maybe while the participants are writing their questions, I may have a few questions to you if I'm allowed. It was really informative, the speech. And then I just had one question regarding of the, I think, slide number 13. It's number 13. If you could, there was a statement regarding saying that I'm not able to read the district name. I'll say 1 and 2, if it is okay. And then because you named them, but I say 1 and 2. So it says that here. So the second remark that it's an interesting. So I think that instrumental period for the years you do have a data for the region, right? For the 8 years in this year. So, but it's correspond to the 100 years reoccurrence period. Is that right? This is my understanding.
I have a data series for of rainfalls for station Mikhailovets 57 years, which is enough for implementation of any statistical technique, and 48 years for the Kladovo.
Okay.
So I analyzed why Dubinská reka have this return period of 250 years, and the Monastirski potok only 45 years. It is because of lower CN number, curve number, as well as because of the lower rainfall precipitation on subject date, but also it is because of the influence of these statistical calculations, which I explained in the second and third paragraph.
Mm-hmm. But your speech title was How Extreme? I think it's really extreme, 25 years that you calculated, the recurrence period. It is really high. And then I just want to put a remark that if Turkey has experienced a 25 years flood reoccurrence, and it's going to cost at least 25 million's life. And then it means that the region faced actually in 2014 an extreme event. So maybe you could tell us that what happened after the disaster, post-disaster management? Do you have any information that you could pass by us?
Yes, of course. Unfortunately, everything is linked to politics and political structures. I am pessimistic in this manner because they do not listen a lot of from the professionals and from academics. I got my PhD degree at the Faculty of Forestry, where I learned a lot of regarding biological and technical anti-erosion and torrent works in the water that should be done in one torrential watershed. And this is recommendation from a professional world. So to do a lot of biological, technological, and technical works in the watersheds, hydrological structures in the rivers, etc. What our politicians do is to cover these material damages and to do a very small part of this protection works, and they think they will have luck to not have another extreme event during their mandate, how to say. So I work for the science. I employ a lot of methodologies in researching this natural phenomenon, and my future work will be dedicated to education of local community, of local citizens, because as you remember, if you remember, the 5 human lives took this torrential flood event in September 2014, and it could not be like that because 2 adults wanted to pass the river in the peak of torrential flood wave, and it was yes, the result was lethal. So there is a need to educate people more, there is a need to speak more with politicians to make right decisions in the direction of torrent and erosion control works in the watersheds. So yes, we now work with one municipality in the Western Serbia regarding their torrents, and we want to do a very detailed study. This is called operative plan for making these erosion endangered areas for detection soil erosion and torrent endangered areas, and to speak more with the local community and the local residents to how to do this, how to implement preventive measures in the watershed, in these especially in these upper parts of watersheds. This is what we can do maybe more to speak with the local citizens. Maybe that will have, maybe this can be more productive than to speak with politicians.
Increasing the awareness. Thank you so much. And then I'm sorry for your losses in the country. And at the same time, I would like to congratulate you on your book. So is it English or your language?
This is in my language, but it has five pages in English.
English,
and in research gate, I can send here the link of my book just to have a impression of in English. So there is a summary in English.
Okay, so if it were in English, I would definitely get. But so maybe I should learn Serbian first, then get the book later on.
Yeah.
Okay, so Dr. Anna Petkovic, thank you so much. So, and we wanted to do something good for the planet, and we donated 5 saplings under your name. So then it's going to be those saplings will have your name. Okay, thank you so much.
I didn't understand. Please repeat me.
Saplings, and those are trees, the baby trees. Yeah, baby trees under your name, and they're going to grow in Turkey, and then we'll have your name. Yeah, 5 of them. Okay.
Thank you.
So thank you so much, and then your attendance, your informative speech. And then I guess that it should be appeared on the screen that you could see. While they're putting your attendance certificate, I would like to inform that we are also live in YouTube. You could follow us on our channel, academic platform too. Okay. And then let's wait a little bit for your, yeah, it's in here. So 5 saplings for donated under your name. Thank you so much. So let's move on to the next presenter. And then Anud Fawaz Mohammed Al Dardasawi. I'm sorry for my pronunciation. And then I think he's not here. And then if he gets online, we are going to, of course, listen to him. But in order to not to lose the time, let's go to the third presenter, Abdul Qaddir Fazel Çağlar. And then the title of the presentation is Calibration of RC Columns Using Fiber Elements. So the floor is yours, Dr. Çağlar, Mr. Çağlar.
Hello, everyone can hear me?
Yes, we are able to hear you. So if when you're ready, okay, you could speak up.
Okay. Okay, hello everyone. I'm Fazel Abdul Qaddir Çağlar. If I have to talk briefly about myself, I'm a research assistant at Bolu Abant Üzzet Baysal University. I'm also continuing my master's degree at Sakarya University. Today, I will present you our article named Calibration of RC Columns Using Fiber Elements. Okay. Experimental studies are one of the most effective methods in examining the behavior of building and building elements. It is possible to have information about the structure or the behavior of the building element without doing experimental work after the computational power increase. It is necessary to verify that the models made in these programs can give results close to the experimental studies at a sufficient level. If the results obtained are suitable, the behavior of the building elements can be obtained in a short time with different variables. In this way, compared to experimental studies, results can be obtained in much shorter time and more results can be obtained by trying different parameters. This study examines the comparison of force-based element and displacement-based element in columns using nonlinear fiber elements. Within the scope of the study, OpenSys program is employed for columns selected from the peer database. side. The aim is to compare the employment of the force-based element and displacement-based elements in RC columns in terms of number of elements and integration points to simulate the global behavior of the columns numerically and to optimize the parameters that affect the results. We selected 6 different rectangular columns from the peer structural performance database sites. As you can see, there are concrete and steel properties in the table. And there's axial load ratio over there. The modeling on OpenSys, the given material properties by the experimental results for each column are used in the numerical models. The concrete elements are modeled using concrete 04 for confined concrete and concrete 01 for unconfined concrete representing the concrete color. Reinforcing steel is utilized from the software library for longitudinal reinforcing bar. The buckling of reinforcing bar is considered and the unsupported length for local buckling is computed for each column. Numerical issues on the distributed plasticity and enlightened physical regulation techniques to eliminate them for the objective and non-objective responses. Those physical regulations, regularization techniques are employed on the numerical models. For force-based elements, the number of integration points is selected using an aspect in which the plastic inch length over the height of the column provides a good approximation. And for the displacement-based elements, the same perspective is implied to height of the first element, employ 2 elements for all cases with 2 integration points in each case. As a result, the results obtained for each selected column using different fiber element types. In general, both element types provide good agreement with the experimental results. The displacement-based element provides a stiffer response and the convergence convergence problem can be observed especially among the models with a high axial load. If we need to look at the graphs here one by one, Bayrak column shows great agreements in both element types, while force-based element shows greater match, especially along with the softening range. On the other hand, the Matamoros column with the force-based element is able to simulate the maximum and elastic zone better. Meanwhile, the model with the displacement-based element shows some dispersions through the softening zone. The pinching behavior is captured better on the model with the force-based element. And though no column model with the force-based element displays a very good agreement on the softening range and able to capture the ultimate displacement. Both models, Sarchiolu column, are not able to capture the pinching, but overall they do have good agreement with the 2 models. And the models for the Sarchiolu column captures pinching very good. However, the model with force-based element shows lower and the model with the displacement-based element higher global response than the experimental results. For the Tanaka column, the model with the force-based element illustrates a better agreement regarding maximum response softening zone and pinching. And the results are compared in details in the slides. You can see experiment tests over there and resulting using force-based elements. And it's very close to force-based element and experimental elements, but the displacement-based element is a little bit different results. We get that. So thank you for your attention. I can answer, is there any questions?
Thank you so much, Fazel. And then, do you have any questions regarding of his work? I may ask you, but I'm your advisor, so let's make it simple then. Okay. So, and then normally, in order to capture the global response of any numerical model, so you have to have optimization regarding of the integration points and also number of the elements. So, but it seems that physical regularization, which is actually making a smart way, and then rather than working on optimization of the number of the elements and then the IP numbers, I think that using one step, you're able to capture the global response of columns very well. So if you show up the table, and then can you say that physical regularization is working perfectly? Perfect is a key vocabulary in here. Just a tip.
No. No, the answer is no.
Oh, right. So, but it's an efficient way to do that. And then it's
the efficient way, displacement-based method gives approximate results, but force-based method gives realistic results. Integration points are important if force-based method is used, but if displacement-based method is used, number of elements is important.
Okay, so good. Those are nice points. Thank you so much. Fazel, Çağlar, and we also have 5 saplings under your name as well, but pardon me, so certification, participation certificate for you. And then thank you so much for your attendance and your hard work, okay? Thank you.
Thank you so much.
So we could move on the 4th presenter. And then on behalf of the the paper ID number 42, and we are going to have Dr. Abdul Özden. And then the title of the paper is Evaluation of Effect of Traffic Signs and Pavement Markings on Traffic Safety in Ribbons. Dr. Özden, the floor is yours.
Thank you very much, Dr. Tatar. Let me start sharing my presentation. All right, it should be up now. Good morning, everyone. Good afternoon for those who are very far from here. Today, I will briefly be talking about the evaluation of the effects of traffic signs and road markings on traffic safety in roundabouts. As we all know, the world population has been increasing, and the number of motor vehicles has been increasing significantly in the last 2 decades. Of course, in some parts, that makes our daily life much easier, but brings other problems too. Emission, fuel consumption, noise pollution, congestion at intersections, and accidents, and the loss caused by the accidents. When we look at the accident statistics, according to World Health Organization, every year 1.3 million people die due to traffic accidents, and nearly 50 million are injured. And in most countries, road traffic crashes cost nearly 3% of that country's GDP in most cases in globally. In Turkey, we lost about 7,000 lives in traffic accidents, coupled with 300,000 injuries. Nearly half of the deaths and nearly 70% of the injuries occur in urban areas, which makes it much more significant for us to focus on the traffic safety at intersections. Among the faults in traffic accidents, driver faults consist the vast majority of the faults. in accidents. Violating speed limits are nearly 40% of all driver faults. But the violating speed limits doesn't mean driving with excessive speed. It's just not driving as appropriate as it's supposed to be based on the design. Yielding or not providing the right of way at intersections consists of 13% of the driver faults, and inappropriate lane changing are the 7% of the traffic accidents. Oops. So what should we do? Well, there is no magic solution, but still a lot to do. Among all, first, we have to make proper design of the road infrastructure. We have to design properly, and we have to apply in accordance with proper designs. The second most important part is the driver education. We are going to see the results that we all know the rules, but we don't follow the rules. And the last part is, of course, the traffic control and enforcement. We have to make proper traffic control management systems, specifically in urban areas, and we have to enforce that the violations should be treated rightfully. What we have done so far, specifically in Turkey, in the last 2-3 decades, we increased the infrastructure capacity, and we increased the effectiveness of the current infrastructure. We increased the number of divided highways and the length of the divided highways. And in difficult terrains, we built bridges and tunnels to make the roads much more safer from traffic safety perspective. From the perspective of technology, we incorporated intelligent transportation systems. We increased our capacity from traffic management systems. We have been we have been actually collecting data from all over our streets, specifically in urban areas. And of course, from the design perspective, we have much more safer cars. We have much more braking capacity and automation in vehicles. And we have been working on the policies from sustainability perspective, from resilience, from micromobility. But as Dr. Petrovic indicated, these are much more political, and we need more time in the long run to apply all these changes as public. So in the improvement plans, in Turkey, we have state development plans every 5 years. And in the last 3 of the development plans clearly states the traffic safety in Turkey. And in the last plan, which was written in 2018 and covers the dates between 2019 and 2013, it's clearly stated that the causes of the traffic accidents should be clearly identified for reducing the accidents and consequently their adverse effects to our daily life. About this, General Directorate of Highways has been proactively working on improving the roadway safety in various stages. And from the roundabout perspective, General Directorate of Highways have published a guideline about the use of the modern roundabouts. So what is a roundabout? A modern roundabout is a circular intersection where drivers travel counterclockwise around the center island. So there are no traffic signals or stop signs in a modern roundabout, but there are yield signs. And drivers who are approaching the roundabout should yield at entry to traffic in the roundabout, then enter the intersection and exit at their desired street or approach. So why we have been promoting the roundabout? The number of conflict points is much less in roundabouts. In a specific four-leg intersection, we have about 32 conflict points that vehicles can have a conflict. In modern roundabouts, this number has been reduced from 32 to 8, 4 in the splits and 4 in the joinings. So this is one of the critical advantage of using modern roundabout, specifically in urban areas. Why? Because while designing the modern roundabouts, they reduce the speed of vehicle entering the intersection and minimizes the possibility of severe of the accidents. Specifically reducing the possibility of head-on collisions. As we said, the number of conflict points at roundabouts is much less than signalized and non-signalized intersections. And lastly, vehicles are enters the roundabout at a slower speed, but generally in constant motion, which reduces the delay time from the perspective of traffic flow. In general, the waiting time is 20% lower in modern roundabouts compared to signalized intersections. So from disaster perspective, as we all know, transportation infrastructure plays a critical role in all stages, from preparedness to response, specifically in the first response and the recovery stages. But besides all, just from the perspective on the roundabouts, as we said, roundabouts has less conflict points. There's a natural flow at roundabouts that vehicles are synchronously moving. And these type of intersections do not rely on power supply, which is traffic lights, which is critical, specifically during an emergency time, power outages. We do not rely on the traffic lights. So the vehicles can flow simultaneously at the same time. Of course, we can see the gridlock in the roundabouts too, but it's going to be the gridlock on regular four-leg intersections are much worse compared to roundabouts. So, what is the aim and scope of the study that we carried out in this perspective? First, we want to visually evaluate the different applications of roundabouts in Turkey. And we administered a survey to drivers from different socioeconomic backgrounds and from various spatial locations. We then evaluate the perception of drivers on the use of the roundabouts. And we try to understand the knowledge level of drivers on traffic signs and road markings. We administered an online survey. We received nearly 650 responses from 50 cities. First, we looked at the descriptive statistics for initial evaluation, and then we used these statistics and then from the post hoc test for evaluating the level of difference of the outcomes. So this shows a descriptive part of the survey respondents. We have a little bit more response from male participants compared to female participants. We have different age groups. We have different education status. Vast majority of the participants know what a roundabout is and experienced driving in a roundabout in most cases. 88% of the participants encounter at least one roundabout on their normal driving routes. And we asked if they have involved in an accident in a roundabout. Nearly 10% of the respondents said they were involved in an accident at roundabouts. Among the responses, who does not involve in an accident, provided information regarding that they had they experienced a near miss in roundabouts, which is they didn't involve in an accident, but they just missed the accident by sudden brake or a sharp maneuver. Then we asked some various questions regarding how they see the roundabouts and traffic flow and traffic safety. Among these questions, the result is we know the rules, but we do not clearly obey the rules. We do not clearly follow the rules. This is one, the major outcome that we get from these questions. And we asked some questions regarding how the roadway infrastructure on roundabouts. Are they physically enough or properly applied on the roads? And we realized that the most questions came up with the high percentages that infrastructure is appropriately planned and applied. And we asked question to those who involved in an accident or had a near miss, whether this accident or coming face to face to an accident have changed the perception of the driver regarding the traffic rules and the use of the roundabouts. And mostly the awareness increased after the accident or experiencing any near miss. They said they follow the traffic rules much better. They are more in compliance with the speed limits. They are approaching the intersections carefully, much more carefully compared to before the accident or the near miss. And they know more about the traffic rules. And we asked the questions, we asked the road markings and traffic signs regarding the use of the intersections and the roundabouts specifically. Most of the respondents provided well answers that they know about the rules. The two of the traffic signs are come up with less, rate compared to others, which is yield and uncontrolled intersection traffic signs. But again, this shows that we know the rules, but we do not follow them. And we used t-statistics and Banfrone test to see the level of difference by gender, by age, by education, etc. We see that there's a difference between men and women among the respondents. Men have a higher number of correct answers from the traffic signs questions compared to women respondents. And then we looked at the level of difference by age. Again, we see that the age group 25 to 34 has much more correct answers compared to age group 18 and 24, which are much younger, who are most probably don't have a driver license or just got a driver license, and the ones who are above 65, which are not probably driving their own vehicles too much. In both cases, the mid-age, the younger mid-age, 25-35 age group had a higher correct number than other groups. So the results revealed that the correct answers given to traffic signs by gender, presence of a driver license, frequency of experiencing roundabouts and accidents has a level of difference. And there's no significant difference observed to the frequency of encountering the roundabout and the driving frequency. So as of conclusion, approximately 10% of the participants were involved in an accident. Nearly 53.3% of non-accident related respondents experienced a near miss. Most respondents know the rules, traffic signs, and road markings well. The participants who experienced an accident or a near miss had a higher correct answer rate than the other participants. But it's seen that the participants' knowledge about the traffic signs is not very low, but the high rates of accidents or accident survival are thought-provoking. It's thought that this result is not at a sufficient level to yield the vehicles in roundabout and obey the rules, although the drivers know the rules. It's thought that the existence of different applications in the roundabouts throughout the country and in the road design that include the central island, although there is no roundabout, also affect this situation. From both traffic safety and traffic flow efficiency, it should be applied as a top priority solution for the relevant institutions to carry out the necessary studies about the roundabouts and to eliminate the information pollution in the drivers and pedestrians. Thank you for your listening.
Thank you, Dr. Yazdan, for your presentation. I would like to get to the question and answer part if there is any. Please feel free to write down your questions on the chat. So if not, I got really curious about one thing. So I may start. So you mentioned at the beginning of the presentation, I stuck there actually. You said that 3% of GDP is equal to the cause of the traffic accident in the country, overall the world. In general.
It's not a general, but in most cases, in most developing countries and some
developing countries.
Yes.
As far as I know, and from my knowledge from the news, we spent as Turkey or general and 3% of GDP to military defense. It is a high number.
It's a high number.
It's as far as I remember correctly, it's a really high number. When I heard it, I just stuck there. It means that we are losing a lot.
Well, we are losing a lot. Yes, you are right.
It's monetary. It's monetary part, but the human. This. Pardon me, I interrupted. Yeah.
Yeah. I mean, it's a lot. It's a big number. The time, the energy, and the money that we lose on traffic is enormous. We are not aware that we have been losing that much money in traffic, so we have to quantify what we have been losing. I'm forcing my students to make some exercise on how much we are losing in intersections or in a route segment. In 1 minute, increasing the, let's say, 30-minute route to 29 minutes, increasing like 1 minute efficiency, reduces the economic perspective. It reduces the cost of that the traffic in a small city, $100 million per year, just 1 minute. So it's a big number.
In total, it's a great number, in my opinion. Yes. So, but the last question that I see, I checked the screen. You mentioned that 10% accident ratio in Roundabout. So, since I'm away from this area, so I found this number high too. I'm not sure, but maybe you could justify this point. So,
that 10% is the 10% of the respondents stated that they have experienced an accident in an intersection. But so it's not general statistic for the traffic accidents in Turkey.
But it is so would you say that it's a high number? So maybe roundabout are not working properly, or let's say that people do not follow the rules for sure, maybe.
Yeah, people do not follow the rules for sure, but some of the traffic statistics, some of the accidents actually do not go into the traffic statistics, the accident statistics, because if it's just a small accident that does not cause much economical loss, then drivers usually do not go with the regular procedure for reporting that accident. But if you ask drivers in a survey if you had an accident or not, the rates are going to be much higher.
Okay, okay. And then thank you so much, Dr. Rosen. I think we missed your certificate. It was shown on the screen, and then we were talking, and then so probably they are going to email you as well.
All right, thank you very much.
Thank you so much, everyone. And then last, I think we have one missing presentation, but I checked that he's not online. So I want to recall the last time. Alnud Fawaz Muhammad Al-Dardasawi.
Yes, I am here. Hello.
Oh, okay. Your name appears differently. So that's the reason. So thank you so much.
Yeah, this is my daughter's name.
Oh, okay. So they got online courses, right? So that happens to me too.
Yes.
Okay. So welcome. So and I passed you. So you're the last presenter here. So and actually we use the time generously because I thought that you're not here. So we do have time. So if you could finalize your presentation around 13:10, I would be appreciate. So the floor is yours. Thank you.
Thank you very much. Okay. Can you see my screen now?
Yes, I'm able to see.
Okay, let's start. So I'm Anud Fawaz Al-Dardasawi, and I'm going to talk about floods and its environmental impacts. I made this paper with my respectful Hoja, Baytullah Iran. Firstly, I want to talk about contains the introduction about floods and the way floods can be caused, type of floods due to size, important characteristics of floods, the consequences of floods on human and environment, the factors contribute floods and forecasting floods, and how to manage and reduce the floods impacts. Firstly, we have to know what's the flood. When water inundates land that is normally dry, this is called a flood. Floods can be caused by a number of processes. Floods are a natural process, but mankind's activities affect flooding. Floods occur at irregular intervals and vary in size, area of extent, and duration. Every flood is different. They can occur suddenly and recede quickly, or may take days or even months to build and then discharge. They occur at irregular intervals, and many decades can pass between significant floods. On the other hand, there are many examples of several large floods occurring within short periods of time. So floods can be caused in a number of different ways. When rain falls over an area of land, some is absorbed by the soil, while the rest become runoff and flows downhill. The area of land that contributes runoff to a particular point is called the catchment. The amount of rainfall, the intensity of the rainfall over time, the temporal pattern, and the distribution of the rainfall over an area of land, the spatial pattern, can all vary widely. The floods that are produced by this rainfall are therefore equally variable. That is, every flood is different.
So, Ms. Al-Dardasawi, so could you share your full screen, please? I'm sorry to interrupt.
Okay.
F5 is working, I guess. Could you please press on F5? Okay, thank you. I'm sorry to interrupt.
You're welcome. So floods can also be caused by other mechanisms. Recent international events have highlighted the risk of flooding from tsunami. Large tides and storm surges can also flood coastal areas. Inlands, earthquakes, volcanoes, or landslips can also cause flooding, as can breach releases in natural or man-made barriers for flooding, such as dams and levees. Heavy intense rainfall can occur suddenly and quickly, raising floods caused by this in minutes or hours after the rainfall are known as flash floods. Flash floods are typically associated with relatively small catchment areas where there may be little or no permanent flow of water, as there is little time to react. Flash floods are particularly difficult to predict and manage in real time. So this is a small example about flash floods. This has happened in Jordan. Jordanian rescuers search for survivors of flash floods at the Dead Sea area. Jordan, Friday, October the 26th of October. Body of a 12-year-old girl was recovered early Friday, a day after middle school students and teachers visiting hot springs in area were swept away by the torrent. Civil defenses officials say the surge caused by heavy rains carried some for several kilometers towards the Dead Sea. So floods can occur slowly. In larger catchment areas, rainfall can build up over hours, days, or weeks. The runoff from this rainfall flows across land and then down gutters, drains, gullies, creeks, and rivers, and may create significant floods that inundate large areas of land for days, weeks, or months. With more time to react, flood warnings is more effective for these types of floods. Sometimes a flash flood in the upper reaches of a river system can evolve into a more general river flood as it joins with other inflows and spreads out as it travels downstream. Many locations can be affected by both flash floods and the more general rivers flooding. For example, a particular residence might be potentially affected by a flash flood through the local gully or a river flood from the nearby major river, or a combination of the two. So floods is a natural process. Floods are a natural process in our ecosystems. River systems and estuaries have adapted over a long period of time to depend on an irregular pattern of large floods. And we as a mankind, we make a lot of changes to our catchment, including land clearing, urban development, dams, that can change the impact of a flood on the natural environment. So floods can vary in size too. The size of a flood event or its magnitude can be expressed in many ways. The peak level of the water at a particular location in a waterway is the most unambiguous way, as it's relatively easy to measure and is the principal driver of flood impact. The flood magnitudes are usually classified by their height, and the Bureau of Meteorology uses three general categories of flooding related to water level. The first one is major floods. This causes inundation of large areas, isolating towns and cities. Major disruptions occurs to road and rail links. Evacuation of many houses and business premises may be required. In rural areas, widespread flooding of farmland is likely. The second one is moderate floods. This causes the inundation of low-lying areas, requiring the removal of stock and or the evacuation of some houses. Main traffic bridges may be closed by floodwaters. And the third one is minor floods. This causes inconvenience such as closing of minor roads and the submergence of low-level bridges, and makes the removal of pumps located adjacent to the river necessary. These other important characteristics of floods that contribute to their severity includes the total amount of water in the flood, or the flood volume. The flood volume contributes both to the level and duration of flooding. The flood mitigation ability of dams and detention basins are less for large volume floods. How fast the flood rises, or rate of rise. A flood that rises quickly obviously provides less time for warning and evacuation. How fast the water is flowing, the flow velocity. Faster flow causes a higher risk to human life, a higher risk of erosion, and more damage to infrastructure. The duration of flooding, a flood that lasts for a longer time, provides a greater impact owing to the increased duration of the disruption of transport, business, and personal networks. The areal extent of flooding, flooding that affects a large area, either within a river basin or across multiple basins, provides greater impacts. The consequences of floods impact on both individual and communities and have social, economic, and environmental consequences. The consequences of floods, both negative and positive, vary greatly depending on the location and extent of flooding and the vulnerability and value of the natural and constructed environments they affect. As most people are well aware, the immediate impact of flooding, including loss of human life, damage to property, destruction of crops, loss of livestock, and deterioration of health conditions owing to waterborne diseases. As the communication links and infrastructure such as power plants, road and bridges are damaged and disrupted, some economic activities may come to a standstill. People are forced to leave their homes and normal life is disrupted. Similarly, disruption to industry can lead to loss of livelihoods. Damage to infrastructure also causes long-term impact, such as disruptions to supplies of clean water, wastewater treatment, electricity, transport, communication, education, and healthcare. Loss of livelihoods, reduction in purchasing power, and loss of land value in the floodplains can leave communities economically vulnerable. Floods can also traumatize victims and their families for a long period of time. The loss of loved ones has deep impacts, especially on children. Displacement from one's home, loss of property, and disruption to business and social affairs can cause containing stress. For some people, the psychological impact can be long-lasting. So the impacts of flooding on humans, people can be injured or killed by flooding. Floodwater is often contaminated with sewage, which can lead to illness and affect clean drinking water. Power supplies can be disrupted. Business can be forced to shut down. Services such as hospitals and schools can close. Transport networks can be affected, such as flood damages, damage to bridges, railways, and roads. Homes and properties can be flooded. People may have to move out of their properties until flood damage is repaired. Possessions can be damaged and washed away. So, impact of flooding on the environment. Wildlife habitats can be destroyed by floodwater. Contaminated floodwater can pollute rivers and habitats. Silt and sediment can destroy crops on farms. Riverbanks and natural levees can be destroyed as rivers reach bankfall capacity. Rivers can be widened and deposition can increase downstream. Trees can be uprooted by high velocity water flow. Plants that survive the initial flood may die due to being inundated with water. Environmental benefits of flooding. The environmental benefits of flooding can also help the economy through things such as increased fish production, recharge of groundwater resources, and maintenance of recreational environments. Floods affecting coastal resources. Many of our coastal resources, including fish and other forms of marine production, are dependent on the nutrients supplied from the land during floods. The negative effects of floodwater on coastal marine environments are mainly due to the introduction of excess sediment and nutrients and pollutants such as chemicals, heavy metals, and debris. These can degrade aquatic habitats. lower water quality, reduce coastal production, and contaminate coastal food resources. Rainfall is the most important factor is creating a flood. This is what factors contribute to floods. Rainfall is the most important factor in creating a flood, but there are many other contributing factors. When rain falls in a catchment, the amount of rainwater that reach the waterways depends on the characteristics of the catchment, particularly its size, shape, and land use. Some rainfall in captured by soil and vegetation, and the remainder enters waterways as flow. River characteristics such as size and shape, the vegetation in and around the river, and the presence of structures in and adjacent to the waterway all affect the level of water in the waterway. So how do we forecast floods? Weather forecasts can provide advance warning of a flood, and seasonal forecast can alert of heightened chance of flooding in the coming months. However, forecasting river levels and flood extent is a complex process that is continually being improved. Some flood forecasting techniques like hydrological models, hydraulic models, data-driven hydrologic models, artificial neural networks, fuzzy expert system design for flood forecasting, adaptive neuro-fuzzy interference system. So how do we communicate and warn about floods? Flood warning system turn forecast into messages designed to reduce the negative impacts of floods. Warning systems should be accurate, timely, and reliable. Prior community awareness of flood risk can make warning more effective. Improving our warning systems could reduce social losses from floods. So how do we estimate the chance of flood occurring? Understanding the chance of different size floods occurring is important for managing floods risk. The chance of a flood event can be described using a variety of terms, but the preferred method is the annual exceeded probability, AEP. A flood with a 1% AEP has a 1 in 100 chance of being exceeded in any year. Currently, the 100 AEP event is designated as having an acceptable risk for planning purposes nearly everywhere. However, good planning needs to consider more than just 1% AEP floods. Thank you for listening. And if you have any question, I can take it now.
Thank you, Ms. Aldarda Sawi, for the presentation. And I would like to move on to the question answer part. Here is your certification of participation. So, and let's move on to the question. Is there any question?
Thank you for listening.
Could you unmute, please, Dr. Petrovich? Yes, thank you.
Very nice. I'm happy that there is one more presentation regarding this type of natural hazard, hydrological hazard floods. I would like to comment with you the situation in August in Turkey. As I am informed, in Turkey there were around 200 forest fires in July, and then on the 11th August, some rainfall stations registered up to 300 millimeters. Yeah, so that was a cause of the torrential floods in the northern Turkey, in the mountainous Black Sea region, in the municipalities of Kastamonu, Sinop, and Bartin. There were around 80 death toll, so very severe torrential flood events, many hospitalized, and I would like to hear the something about what your government planned to improve flood risk management in your country. And I would like to hear from you in, I don't know, in next year, maybe the analysis of this torrential flood event. So yes, I have in my presentation my email address, so you can send me some analysis and publish papers on this topic in future. Thank you.
Thank you, Dr. Petrovich. I guess this went to me, right?
Yes.
Yes. Okay. So I'll try my best. This is out of my area. So I work on risk, general multi-risk analysis. That's I know a little bit knowledge about that. But of course, after the disaster, post-disaster management should come, and then the city is under reconstruction. I think it's pretty much has been done in many structures, and then it's still ongoing though. Regarding of the post-disaster management, we are right now doing a project. First of all, we are talking about the bridge piers and then impact of flood, plus that you know that the large woods that hit in the bridge piers, so that impacting like a concentrated load impact right now working on. And after that, so we are going to work on how to prevent those, and maybe there are like we will suggest some stations that catch some greater particles before hitting the infrastructures and causing a greater damage. So working slowly on that part, but still I'm looking at the problem as a risk and loss analyst. And I will convey your question to my colleague, which we are working together and writing the articles together. And definitely he's going to reach you out. And then thank you. Regarding of the presentation, is there any question? And then I do have one small question. It's a small question. I didn't understand how really a flood influences on the fish production increment. So I didn't get that part, because maybe that's the way that I look at the problem is a disaster part. So I see flood as a disaster and should be managed, but maybe Ms. Aldardasawi could help me to understand this part. But she's muted. I guess she's not able to hear me. Maybe I'll catch her later on. Okay, so I would like to thank everyone for joining us in here. So, and with the patience, and then and after, I think that this is the final of the session. I want to just check the program. It restarts at 2. I don't want to say something wrong. 2. Yes, 2 a.m. with a keynote speaker, Dr. Doğan Kalafat from Boğaziçi University. The title is Seismicity of Turkey and Contribution to Seismic Network of Determination of Earthquake Hazard. So you're really welcome to listen to him and then following sessions as well. And the next session will be moderated by Dr. Petrovich too, I know. So thank you so much, everyone, and see you next session.